So my name is Antoine Bouet. I'm professor at University of Bordeaux and senior research fellow at IFPRI. And I'm going to give you a first view on how to program computable general equilibrium models. So why do economists design CGE models, that is to say, computable general equilibrium models? Because these models are used to provide ex-ante evaluations of policy reforms. What does it mean? Well, let's imagine that a government like the French government or the US government or a supranational institutions like the European Union study the consequences of a specific policy reforms. So it could be a trade agreement, it could be a policy support to the development of specific value chains like the biofuel value chain. So for this government or for these institutions, it can be interesting to require the design of a CGE model in order to have an ex-ante evaluations of this policy reform. That is to say, an assessment of the economic consequences of these reforms before its implementations, and we can have with this model consequences on production by sector, exports, imports, consumptions, employment, and so on. And so for doing that, general equilibrium models are interesting because they are consistent and because they are also based on economic data, real economic data. And of course, at the same time, they are more complex and more demanding. So why do we say that CGE models are consistent? Because under general equilibrium model, interdependence between markets and income effects are taken into account. So we take into account interdependence between good markets and factor markets, and we take into account income effects, that is to say how changes on factor markets or government policy affect income of all agents within an economy. So this type of models is consistent, and as I said earlier, these models can be calibrated on real data in order to simulate policy changes. So we need in particular much economic informations, and in particular social accounting matrices. You know what is a SAM, or a social accounting matrix. It's a representation of economic flow of all economic transactions that take place within an economy. We need also the estimations of behavioral parameters like income elasticities, price elasticities, in order to get the importance of the economic relations between two variables. For example, income and demand. So you see that a general equilibrium model is consistent, but it is also very demanding in terms of data. What is the main principle of general equilibrium models? Well, this is the interdependence between the formations of equilibrium on different markets. So, equilibrium on one market depends on equilibrium on other markets. For example, demand on the automobile market depends on demand for automobile. And this demand depends on automobile prices, but also on households' income. This income depends on what's happening on the factor markets, and in particular the labor markets, which determines the level of employment and the level of wages. This is why an equilibrium on one market, automobile, depends on equilibrium on other markets, in particular here the labor market. Of course, it works this way, but it also works the other way. And you can think about why equilibrium on the labor market depends on the equilibrium on goods market. The explanation is very simple. So it means that under general equilibrium, all prices and all incomes may vary, while under partial equilibrium, we may focus on the equilibrium on one market. And we can suppose that incomes are constant and prices of other goods are constant. So this is why general equilibrium models are completely different from partial equilibrium models. An interesting implication of this interdependence is that if there is disequilibrium on one market, then there is disequilibrium on at least another market. Why? Because the initial disequilibrium is going to give birth to a change in price, and this change in price will affect other markets. Another way of presenting this is to say that if there is equilibrium on n minus 1 markets, there is equilibrium on the last market. This is what we call the Walras' law, as it was first inspired by Léon Walras. I'm going to give you now simple illustrations of what is a general equilibrium model, and I'm going to adopt a certain number of simplifications in order to present a simple general equilibrium model. So we consider an economy with only one agent. There is no government and there is no relations with the rest of the world. So this economy is in autarky. And there is no investment. The income comes from production, and this income is entirely consumed, so it means that there is no savings. There is a production process, and it follows a certain technology, which is a Cobb-Douglas technology, and this technology associates capital and labor to produce a unique good. So capital and labor demand generates an income, and so as there is only one agent who owns the capital and labor factors, it means that the total income belongs to the single agent. And finally, the equilibriums on the three markets is obtained through an adjustment of prices. These three markets are the output market, the capital market, and the labor market. So for this general equilibrium model, I'm going to adopt a certain number of annotation. So I'm going to call KD the demand for capital, LD the demand for labor, Y the productions of the unique good in volume terms, INC the income, C the demand of the unique good by the single agent, P is the price of the unique good, R is remunerations of capital, and W is remunerations of labor. So I need other annotations, so I call KS the supply of capital, LS the supply of labor, alpha is the elasticity of production to capital, and A is the global productivity of factors. So I'm going to suppose in this model that KS and LS are constant. In fact, they are exogenous. They are not explained by the model. And we can change, of course, these assumptions, and we can have some equations that explain the supply of capital and the supply of labor, but here this is not the case. So KS and LS are exogenous, and alpha and A are parameters. So it means that in this model we have 8 variables: KD, LD, Y, INC, C, P, R, and W. And so it means that we need 8 equations in order to be sure that we have enough information to find a solution to the model, and these equations, of course, have to be independent. So what are these 8 equations that we need for finding out a solution of the model? First equation is the production process, which follows a Cobb-Douglas technology. This is equation 1, and it is Y is equal to A multiplied by KD to the power alpha multiplied by LD to the power 1 minus alpha. So it's a Cobb-Douglas function. The second equation is the demand for capital, and it comes from cost minimizations. If we minimize costs of productions under the constraints of getting a certain level of productions, we have equation 2, which is R multiplied by KD is equal to alpha multiplied by P multiplied by Y. Same thing for labor. So the third equation is the demand for labor, which also comes from the cost minimization. So we have Y multiplied by LD is equal to 1 minus alpha multiplied by P multiplied by Y. The fourth equation is the distributions of income from productions. I remind you that the single agent owns the capital supply and the labor supply, so it means that the income will go to the single agent, and this level of income is INC is equal to R multiplied by the supply of capital KS plus the remunerations of labor, which is W multiplied by LS. The fifth equation is the level of consumptions by the single agent. This level of consumptions is only limited by income. I remind you that there is no other period of time, so it means that the income is entirely consumed, and so the level of consumptions is only limited by the level of income, so it means that the level of consumptions is given by P multiplied by C is equal to INC, the income of the single agent. And we have the three other equations, which are equilibrium on each market. The sixth equation is equilibrium on good market, C is equal to Y. The seventh equation is the equilibrium on capital market, which is KD is equal to KS. And the eighth equation is the equilibrium on the labor market, and it is LD is equal to LS. We have 8 equations and 8 variables. But there is a big problem, which is characteristics of all CGE models. There are 8 variables, but there are only 7 independent equations. So there is one equation which depends on the others. And it is a characteristic of general equilibrium models because by nature, in fact, equilibrium on the different markets are dependent on each other. So here I can prove that if equation 2, 3, 4, 5, 6, and 7 are verified, then equation 8 is verified. So how to demonstrate this? So consider equation 6, which is C is equal to Y. I can multiply by P, and then I can develop and transform according to this. PC is equal to PY is equal to alpha PY plus 1 minus alpha PY. So if I take into account equation 2, which is the demand for capital, which is RKD is equal to alpha PY, and equation 3, which is the demand for labor, which is WLD is equal to 1 minus alpha multiplied by P multiplied by Y. I can also take into account equation 5, which is PC is equal to INC. This is the equations of demand for the unique good. I obtain something which is INC is equal to RKD plus WLD. So if I take into account right now equation 4, which is the formations of income, which is INC is equal to RKS plus WLS, and equation 7, which is the equilibrium on the capital market, which is KD is equal to KS, I obtain something which is RKS plus WLS is equal to RKS plus WLD. So I can simplify first by RKS, then I can simplify by W, and I obtain LS is equal to LD, which is equation 8. So it means that if equation 2, 3, 4, 5, 6, and 7 are verified, then equation 8 is verified. So it means that 8 is not independent from the other equations, and so I do not have 8 independent equations, but only 7 independent equations. So it means that I do not have enough information to find out a solution. So it means that we have 8 variables, but only 7 independent equations. So the model is underdetermined, and so it has many solutions. So how can we fix this? Well, we can keep one variable constant, it leads to 7 free variables and 7 independent equations. So in fact, the solutions is very simple. I'm going to, for example, assume that the variable p is going to remain constant. It's equal to 1. So in fact, it's a choice of a numeraire instead of working on euros or US dollar. We work on with a new numeraire, which is the output. Okay, we could have another price which remains constant and which is used as a numeraire. It could be labor, for example. So it means that the new numeraire would be units of labor. And so with this price which remains constant, it means that we do not work with nominal prices but relative prices. All the prices are defined relatively to the new numeraire, which is here the output, the unique output. So I can have with this solution 7 free variables and 7 independent equations. But in fact, I would like to keep the labor market equation. Why? Because this is an important equation of the model. And so I'm really embarrassed if I do not have a labor market equation in the model. So what we could have maybe is to have 8 free variables and 8 independent equations. How can we do that? That's very simple. I'm going to create a new variable which is called Léon, in honor of Léon Walras. So it's a new variable. It is initialized on 0. And I add it to the labor market equation. And so the new labor market equations is LD is equal to LS plus Léon. So it means that when the other equations of the model are verified, it implies that LD is equal to LS, but not LD is equal to LS plus Léon. So it means that these new equations, LD is equal to LS plus Léon, is independent from the other, because in fact Léon can vary, can take any value, and so this new equations is independent. And so with these solutions, so it means that first I adopt a numeraire, which is here p is equal to 1. I create a new variable which is Léon, okay, which can take any value, but which is initialized on 0. And I change my equations, which was not independent. I change it I added the variable Léon. So it is changed for LD is equal to LS plus Léon. So now it is independent from the other equations, and I have 8 free variables and 8 independent equations. I have enough informations to solve the model. This is the model, the CGE model, with 8 equations and 8 variables. So I'm going to describe this model by blocks. So the first block is a production block, the second block is the income block, the third block is the consumption block, and the fourth block is the equilibrium block. So first block is production, is about production. So equation 1 is about the production function, which is a clubbed glass. Equation 2 is demand for capital. Equation 3 is demand for labor. The equation 4, this is the second block. It's about the formation of income coming from the ownership of productive factor. Then we have a third block, which is about consumption. And so this is the final consumptions by the unique agent. And then we have a third block of equations, which is about equilibrium on each market. So equation 6 is about equilibrium on the good market. Equation 7 about the equilibrium on capital market, and equation 8 is about equilibrium on the labor market. You take notice that concerning this last equation, we do not have demand for labor is equal to supply of labor, but we add a variable which is Léon, which is free, which can take any value. And so it means that now, with this specification, this equation is independent from the others, because when the 7 other equations are verified, this equation is not verified because Léon can take any value. So it means that we have 8 independent equations, and we have 8 free variables, which are Y, the production, R, the remunerations of capital, KD, the demand for capital, W, the remunerations of labor, LD, the demand for labor, INC, the income, C, the consumption, and Léon, which is the Valras variable. We add one restrictions. P is remain constant at 1, so it means that it's a numeraire. In fact, all the prices are relative prices relatively to the price of this unique good produced in this economy. We have 8 independent equations and 8 variables, free variables.